Wow, this is so beautiful. Hey, we're in a different setting today. We have no whiteboard, but guess what? We'll still be giving you a video. Welcome once again to Math with the Real Floater. Today, we'll be digging all into the addition of fractions. Let's get into it. I've been walking all over this property, can't find nothing to write on. Whoa, I gotta go somewhere. I gotta find something to write on today, man. Oh man, I gotta do my video. I have to do my video. Guess what? Let me check with the front desk. They're bound to have some. Today, we'll be focusing on addition of fractions. Welcome to Math with the Real Floater. All right, the last time we spoke on proper fractions, improper fractions, mixed and equivalent. And we spoke about if we have a fraction such as 1 over 2, 1, the top section is called the numerator. And the bottom section is called the denominator. All right? So please get familiar with those terms. All right, good. Yeah, we have a different way of teaching today. There is no whiteboard, so we have to suffice and be very creative. All right, let's say we have two fractions, 2 over 7 plus 3 over 7. If you realize the denominators are the same, okay? And when we have the denominators being the same, the only thing we do, we just add the numerators and put it over the denominators. So in this case, we'll be adding 2 plus 3. Those are our numerators. And we put it over the number 7. Okay? So the answer for this addition of the fractions would be 5 over 7. So whenever we have the denominators being the same, all we do is to add the numerators and put it over the denominator. That's all. That's all to it, as simple as that. So these are two proper fractions that we just added. All right. All right, so let's do another one. We have 6 over 23 plus 4 over 23. Once again, our denominators are saying the same, and the denominator is 23. So all we do is just add our numerators, which will be equal to 6 plus 4 is 10, and we just put back the denominators. When the denominators are the same, when we add our fractions, we just add our numerators, put it over the denominator. I may sound like a scratch record, but I've seen where people make a lot of mistakes in this regard. All right, let's do another so we understand exactly what we are getting into. We have 3 over 5 plus 4 over 5, which is the same thing as the denominator are the same, so all we do is just add the numerators, which will be 7 over 5. All right? And what's that 7 over 5? It's the answer, yes, but I like to break things down. In our previous video, I would have shown you how you break down, this is what you call an improper fraction. That's when you have the numerator being larger than the denominator. So we can break this down. And we do so by saying 5 into 7 goes 1 time. Okay? Leaves a remainder of 2. And we put this back over the denominator that we have, which is 5. So 3/5 plus 4/5 equal to 7/5. And I don't like leaving answers in an improper way, unless the exam asks you to leave it as an improper fraction. But if it doesn't ask you that, we break it down into a mixed number, which is 1 and 2/5. So if you don't understand improper fraction and mixed numbers, please, you can get back to our previous video. If you don't understand the concept of mixed and improper fraction, go back to my previous video where we spoke about introduction to fraction. Come on guys, if you love this content, please subscribe. Turn that notification bell on. Like and share. This is Matt with the Real Floater. Alright, let's look at another. Because they say practice makes perfect and repetition is the mother of all learning. Repetition is the mother of all learning. Alright, we have our denominators being the same, which is what? 9. So we can always put this back because that number will not change because we're adding fractions. So we'll just add our numerators. 5 plus 4 equals to 9. Okay. Do we leave that in this form? No. We break it down to 9 over 9 is the same thing as 1. Okay? Same thing as 1. So I like to do these simple examples because sometimes people do make mistakes and sometimes they leave it as 9 over 9. So any number over the same number equals to 1, except 0 of course. Alright, that's a whole new different section right there. Now, if the denominators are not the same, okay, this is how we do it. If the denominators are not the same, this is how we do it. So if we have 1 over 7 plus 2 over 3, remember we're adding our fractions. In this case, the denominators are not the same. Alright, so this is what we do. You have several ways in doing it, but I like doing it the easier way and the more efficient way as well. We have 7 and we have 3. What we need to do is to find a number that these two numbers can go into without leaving a remainder. As a matter of fact, you want that lowest number. You call that the lowest common multiple. You want the lowest number that both denominators can go into without leaving a remainder. Okay? Both numbers can go into without leaving a remainder. The trick to it is this. Always choose the larger number and just write down multiples of that number. Can 3 go into 7 and don't leave a remainder? No. Can 3 go into 14 and don't leave a remainder? No. Can 3 go into 21 and don't leave a remainder? Yes. Remember, we need to know our tables. So what we do is to draw a line right here and place this number that we call the lowest common multiple down at the bottom, alright? And this is how we do. We work with the denominators and divide them into 21. 7 into 21 goes 3 times. 3 times 1 equals to 3. Then we add. 3 into 21 goes 7 times. 7 times 2 is equals to 14. Remember, we're working with the denominators. So we said 7 into 21 goes 3 times. 3 times 1 is 3. We put our 3 right there. 3 into 21 goes 7 times. 7 times 2 is 14. So we divide by the denominators, and then what we do is to multiply by the numerator. That's all we did just now. Okay? So we have 14 plus 3 is equals to 17 over 21. So that's our answer. So what we just did a while ago, we have the two denominators which are not the same. So what we do was to find the lowest number that each of them can go into without leaving a remainder. What we did, we used the larger number and find multiples of that larger number. So we focus on the larger number, find multiples of that larger number, and then we find out the lowest one that 3 can go into without leaving a remainder. If it went beyond these numbers, you just keep on going until you find that number that both of them will go into and don't leave a remainder. So this is how we did it. The denominators into this number times the numerator. Denominator into this number times the numerator. That's all we did. Not difficult at all. Let's do one more where we have a half plus a third. What's that number that both can go into and don't leave a remainder? Let's work with multiples of 3, which is the larger number. So we have 3 we have 6, we have 9, we have 12. If you look closely, 2 can go into 6 and 12 and don't leave a remainder. But what we do, we choose the smallest number that we see, okay, which is the number 6. Okay, 2 into 6, 3 times. 3 times 1 is 3, plus 3 into 6 goes 2 times. 2 times 1 is 2. Alright, so we add the numerators now, which is 5, and we put back our denominator, which is 6. Okay, guys? This is how we do it when we add fractions where the denominators are not the same. Come on, guys, if you love this content, please subscribe. Turn that notification bell on. Like and share. This is Matt with the Real Floater.